Hello physicists, in this video what we're going to be talking about is the notion of how a vector changes. Okay, now let's say we have a vector A. This will be the vector we'll be referring to. Now there's several ways in which vectors can change. So vectors can change in one of three ways. Okay, so the most obvious one is if the magnitude can change. The magnitude changes. So if just the magnitude changes. So if we have A initial, okay, this is vector A initial. Then, if it changes to A final, if the magnitude changes, becomes longer or shorter, then we say the vector has overall changed. Okay, so case one is if the magnitude of the vector changes. Now, the other two cases are a little less obvious. Okay, our second case is if the direction changes. And only the direction changes. Okay, so whether you like it or not, if the direction of the vector changes, but the magnitude doesn't, then it still technically counts that the vector has changed by some amount. Okay, so if it was facing right before, but it's still the same magnitude, but now it's facing down, it's facing downward, then the direction has changed and thus the vector has changed as well. And the final one is if both change. So both the magnitude and the direction changes. So if we have A initial, and now we have a much longer vector, A final, and also pointing downward, then both have changed, and the vector has therefore changed as well. Okay, and we denote vector change using the Greek letter delta. Okay, so delta A is the change in A. Okay, and we define delta A. So delta A is a vector and is defined as the vector difference of the final vector minus the initial. Okay, so that is delta A. Okay, and that means if you just use some algebra, it means that the final vector should equal the initial vector plus the change in delta A. And this is important once we start getting into motion and other places where vectors might change over time. Thanks for watching. See you next video.